Hello, back again for some more one-step word problems, one-step equation solving rather, and this time we're going to take from words and be able to write the equations. And if you have me, you have done this top part with I have who has game, only we've done it with expressions. So there's one special word we're going to be looking for that my class hasn't looked for. If you have Mrs. Beach and Mrs. Bradford, I know you've also covered this, so this shouldn't be anything spectacularly new. The one new word that we're going to be looking for is the word is, because every time I see that word is, that is where my equal sign will go. And so I tell my kids to find the number. So I have 54. And where the is located will be an equal sign. So 54 is. So I know that everything else that's coming after is going to be on that side. And I apologize, keep zooming kind of in and out on this there for some reason. The sum of a number n and 15. Well, the word sum is going to tell me to add. So I want the sum of a number n and 15. So that means I'm going to add n plus 15. And since it says n and 15 here, if you wanted to write it down here, you could. It's kind of tough with that words up there, but my equation is going to look like this. 54 equals n plus 15. I'm going to solve it using the same steps that we used in the first video. And that means I'm going to draw a line through my equal sign, and I'm going to find my variable. And what's happening in my variable? I'm adding 15 to it. So to undo that, I am going to subtract 15. Whatever I do to one side, I have to do to the other side to keep my boat balanced there. 15 minus 15, those cancel out. And then my n is the only thing left. So 54 minus 15, I have to borrow to do that, and I'm going to get 39 for my answer. So n equals 39. In my next one here, I have a number divided by negative 5 is 15. And so I'm going to go is 15, and it says a number. It doesn't tell me what that number is, so I'm going to say a number. That's going to be my variable. So I'm going to call it n, since we had n in the one before that, divided by, well, that's just the division sign. And I'm dividing it by the negative 5. Now, as I said before on the other page, I'm going to start writing my division problems as fractions. So if I write that as a fraction, I'm going to get n over negative 5, n divided by negative 5. Sorry, you guys couldn't see what I was writing there. That's not helpful. Equals 15. Well, my n is my variable, and it's being divided. And so since it's being divided, I'm going to undo that by multiplying. Since I'm dividing by negative 5, I'm going to multiply by negative 5. I'm going to pop it over 1 because it's a fraction in that n over negative 5 form. When I do that, my negative 5s are going to cancel out to 1s, so I get n over 1, which is just the same as n. And that is going to be equal to negative 75. So my n equals negative 75. And I'm going to caution you guys, make sure if you have a negative sign there next to an equal sign that you leave some space. Do you see how down here it kind of blended into it? And as soon as I just give it a tiny bit of space, then I can tell right away whether it was negative or positive. There's no question about it. And I won't have to worry about getting my answers marked wrong because somebody could not see what I was trying to communicate there. My next one, I have 14 less than x. And when I see that less than, when I see less and than together, that means that 14 is going to go after the x. So I know my is the equal sign, and I have a negative 24 here. I just said because that's the less than, my x needs to go out front, and less than is going to be subtraction, so minus 14. When it's addition, if I stick it out in front, it's not as big of a deal. But when it's subtraction, if I stick it out in front by accident, that can cause some problems. So we want to make sure that we didn't accidentally write that as 14 minus x. That's going to give me a completely different answer. So in this one, I'm subtracting 14, so I'm going to add 14 to both sides. And I get that x is equal to, well, negative 24 plus 14. I'm going to get a negative 10 for my answer. If I had written that as 14 minus x by accident, if I had written that as 14 minus x equals negative 24, I would have been like, oh, well, I'm adding 14, so now I need to subtract 14 from both sides. If it's out there in the front and it's positive, there's no plus sign, but I know that I am adding it. It's a positive number, so I know I need to subtract it. Well, then I end up with a negative x equal to a negative 38. Do you see how this is going awry quite quickly? Well, since this is a negative 1, there's a negative 1 being multiplied here. I'm going to divide by negative 1, which means that both of these, this will become positive because a negative divided by a negative is a positive, and negative 38 divided by negative 1 would be a positive 38, and that is not the right answer. So you can see how being able to read those words correctly and get things in the right order is very important. Our next one says the product of negative 6 and a number. So product tells me that I'm going to multiply, and I'm going to multiply negative 6 and a number. Now I don't know what that number is, so that's going to be my variable. So negative 6 and x, and I put that number, the coefficient, out in front of my variable, if you remember. Here is my is, so that is my equal sign, so it equals 60. So I am going to, since I'm multiplying, I'm going to divide to find the answer, to figure out what x is. So I'm going to divide fractionally there. Negative 6 divided by negative 6. Well, negative divided by negative gives me a positive, and 6 divided by 6 gives me 1. So I get 1x. We don't typically write the 1, so I could rewrite it as x, and then I've got 60 divided by negative 6, which is going to give us a negative 10. I'm going to plug these all back in to check and make sure that my answers are correct. That one works out. Negative divided by negative gives me a positive, and 75 divided by 5 is 15. Now, if you ever plug one in there and you go to check it and it doesn't work out correctly, this is what that would look like. So I've got my x minus 14 equals negative 24. We said it was negative 10 minus 14, so negative 24 does indeed equal negative 24. Now, if I had done something wrong there, say that I had gotten that my answer was negative 9 by accident, and I went back and I said, oh, x minus 14 equals negative 24, and I think that is negative 9. When I get down here, I would catch myself because, well, negative 23, sorry there, negative 23 is not equal to negative 24. This does not work out. So this does not check out. That means that my answer that I got must have been wrong. So if I had gotten negative 9 by mistake, when I go to check it, I should see, oh, wait, that doesn't work out. That can't be the right answer. Coming right down here to my last one then, hopefully plugging an incorrect answer in there did not confuse anyone. Negative times a negative, again, is a positive. 6 times 10 is 60. And that checks, and I get my correct answer. Now, if you're thinking that's all well and good, but don't typically hear people speaking like those problems up above. You're right. We don't typically see those unless we're in math class or we're thinking about a problem in a certain way. Sometimes when you take situations and break them down in your head, they're going to start out like these real life examples we're about to talk about. And then you start to break them down in your head and they start to look like the ones above. That's when you know you've hit real mathematician status. So I have a movie making a profit of $3.2 million. And this is $2.7 million more than it costs to make the movie. So they've made a profit here. What I want to find out is how much of a profit did they make? So the movie makes a profit. In other words, I sell tickets and I get so much money. But how much money does the movie company actually make? Because it did cost something to make the movie. So $3.2 million, first of all, is $3,200,000, in case you didn't know. And what I'm thinking here is the profit that the movie company made, that's going to be my X. So I know that some amount of money that they made, their profit, plus the $2.7 million that it cost to make it, will give me my grand total of $3,200,000. So what's happening to my variable here? Well, it's being added on to. So I'm going to subtract that out. And once again, I'm sure you might be thinking, Mrs. Williams, I wouldn't have thought about it that way. I would have just subtracted them in the first place. Once again, I get it, but we're trying to teach you these steps with very easy problems that you could do other ways so that you have the opportunity to see what it looks like in an easy format. And so we find out that the movie company made a $500,000 profit. Now, something more on your level in terms of something that might actually happen to you. You might not be making movies anytime soon. Maybe you are. But if you're babysitting and you make $5.50 for every hour you babysit, how many hours? So they want to know how many hours. I'm going to call that H. I'm going to make my variable H. How many hours do you need to babysit to make $46.75? Well, each hour that I babysit, I could keep adding $5.50 and $5.50 and $5.50 and $5.50, but repeated addition is just multiplication. So $5.50 times the number of hours that I work. I don't know how many, but I need to make that much money. So I'm going to divide. I'm multiplying here, so I'm going to divide both sides by $5.50. $5.50 divided by $5.50 gives me 1, which I don't have to write. And $46.75 divided by $5.50 is going to give me 8.5 hours when I do that. And as I'm doing these, I strongly encourage you to pause the video, go try it on your own, and then come back and look at it and see if you got the same answer as me. Our next one is the drop on Kings Island roller coaster. The beast is F feet. So they've already told us that the drop on the beast is what we're looking at as our F. A drop on the Diamondback is negative 215 feet, which is 81 feet lower. So we're looking at a negative 81 here than the drop on the beast. What is the drop on the beast? So the drop on the beast minus 81 more feet, so a drop of 81 more feet, is going to give me the drop on the Diamondback, which is negative 215 feet, which is why I have not ridden the Diamondback, but I have ridden the beast. There's my variable there. I'm subtracting 81, so I'm going to add 81 to both sides, meaning that the hill on the beast is a little bit shorter, but it's still a very good drop. It's a 134-foot drop, so I could say it's negative 134 feet, or I could say it's a 134-foot drop. Either one of those would work. Our last one here is a rectangle, and the rectangle has an area of 66.5 centimeters squared, and the width is 7 centimeters. So what is the length? We're going to denote that with an L. So area is equal to width times length. So we're going to divide to find our answer. And we'll find that the length is equal to 9.5. So this is going to be 9.5 centimeters.